There's a hidden technological revolution happening all around us. It's inside your car, it powers your phone, your printer, but it's so tiny you'll literally never see it. So today, let's pull back the curtain on the incredible world of microscopic machines.
Okay, just take a look at these images. On the left, that's not some giant monster. It's a spider mite, standing on a set of fully functional gears. And on the right, that thick, giant cable, that's a single strand of human hair resting on one of those gears. This is the world we're talking about, a world built on a scale that is just mind-boggling.
So, what in the world are these impossibly small devices? Well, they have a name, MEMS. And we're about to break down exactly what they are, where you're using them every single day, and why they represent a genuine micro-revolution.
All right, so MEMS stands for Micro-electromechanical Systems. Now, the most important thing to get right off the bat is that MEMS isn't just one thing. It's a process. It's a whole new way of manufacturing that lets us combine microscopic mechanical parts, things like gears and levers, with all the electrical smarts of a computer chip all on one tiny little device. The best way to think about a MEMS device is like it's a tiny little body. You've got the microsensors, those are its eyes and ears, detecting stuff like motion or pressure. Then you have the microelectronics, that's the brain, figuring out what all that information means. And finally, the microactuators, those are the muscles, creating a physical action. It's a whole, functioning system on a microscopic scale.
But here's the big idea, the thing you really got to grasp. This is not just about making things smaller. This is a totally new way to build machines. It uses the same fabrication techniques that gave us computer chips, which lets us manufacture incredibly complex functions on a scale that was just, well, it was impossible before.
Okay, so that's the theory. But so what? How does any of this actually affect you? Well, it turns out these little machines are the unsung heroes of your daily life. Let's start with a question you've probably never really thought about, but the answer could literally save your life. How does your car know, in a fraction of a second, that it's been in a crash and that it needs to deploy the airbag? This right here perfectly captures the MEMS revolution. The old way, it was these clunky mechanical contraptions, heavy, complicated, and they cost hundreds of bucks. The MEMS way replaces all of that with a single, tiny silicon chip, an accelerometer, that does the exact same job, but it's way more reliable, and it costs just a few dollars. And I mean, just look at the size difference. It is staggering. That little black square on top of the penny, that's the entire sensor system. This one application proved how incredibly reliable and cheap MEMS could be, and it basically opened the floodgates for it to be used all over the automotive industry. Okay, next up, let's move to a device that you almost definitely have in your home or office. Ever wonder how your inkjet printer fires thousands of perfectly aimed microscopic ink droplets to create a super crisp image? Yep, you guessed it. The answer, once again, is MEMS. So deep inside the print head, there's an array of these tiny little resistors. And when a signal zaps it, a resistor heats up at a mind-blowing 100 million degrees Celsius per second. This flash boils a tiny bit of ink, creating a vapor bubble that expands and shoots a single perfect droplet out of a nozzle. And the most amazing part? There are no moving parts. The only thing that moves is the ink itself. Now, to give you a sense of the scale of this, by the year 2000, over 350 million of these MEMS-powered inkjet units were being sold in a single year. This isn't some niche lab experiment. This is a mass-produced powerhouse technology. And the impact is just as massive in medicine. This MEMS tech led to these disposable blood pressure sensors that just connect right to a patient's IV line. I mean, they replaced these bulky $600 devices with a simple, sterile sensor that costs just $10. A game changer. So MEMS has already totally transformed our cars, printers, and hospitals. But believe it or not, that was just the warm-up act. The next wave of innovation is where things get really, really interesting. Just look at where this is all going. We're talking about lab-on-a-chip devices that can give you instant medical results, or ultra-fast optical switches, basically microscopic mirrors that can direct internet traffic at the speed of light. And even tiny radio components that are going to make all our wireless gadgets smaller and more powerful than ever. People saw this coming. Market forecasts from back in the early 2000s were already predicting this explosion. Just look at telecommunications. They were forecasting a growth of over 128% a year. That shows you exactly where the energy was, connecting our world in ways that were faster, smaller, and cheaper than we could have imagined. And hey, this isn't science fiction. This image here, It's a real BioMEMS device, a lab on a chip with channels so small they can guide individual red blood cells. The dream is to one day perform incredibly complex medical procedures, like analyzing or even treating single cells, all inside a device like this.
Okay, so let's bring this all home. Why does this invisible technology matter so much? Well, it matters because it represents a fundamental shift, a completely new way of building the world around us.
And look, this didn't happen overnight. The core ideas have actually been around for decades, but it was really in the 1990s and 2000s that the technology finally hit its stride. The costs just plummeted, and suddenly the applications started exploding everywhere.
And that brings us to what might be the most important idea of all. The first micromanufacturing revolution gave us the computer chip, the brain. MEMS is the second revolution. By adding all these tiny mechanical sensors and actuators, it gives our digital world eyes, ears, and hands, letting it finally interact with the physical world all around us.
This unseen technology has already reshaped everything, and it leaves us with one heck of a question to chew on. What are we going to build next when our machines become the size of a single living cell?